2 and 3, a day of review of 4 and 5, right? So, but pretty much we're not learning anything else after today, which is nice. So this is my integral checklist. And I'm on level 8, right? Level 8. We just have to look out for everything else we've tried fails, okay? So we're looking for the inverse trigs. The outline I gave you from Sean's outline has other, it has all of the other inverse trigs in it, right? So you can see number 20 is an inverse arcsecant. I didn't teach you that, so I'm going to restrict it only to arctan and arcsine. Okay, just to simplify it somewhat. But we might see something like this, the integral of 1 over 4 plus x squared dx. So, do you recognize it? Probably not. Is it a power rule? Hell no. Is there a whole function that you see and its derivative? No. Is there a clear inside? If it was, it would be x would be the inside, right? Because I have an x squared. Doesn't do much for me, right? Because if I said, okay, x is the inside, right? So u is x, right? Du is dx. What happens is I change this to 1 plus 4 over u squared du. It's the same problem with different variable. Good. So then we're to our next one. The downstairs is our u, right? U is 4 plus x squared. Then du is 2x dx. I can get the 2, but I can't multiply by x. I can't multiply by a variable to make it work. I can't do times 2x and divide by 1 over 2x. Right? Why? Why can't I do that? More than that. My operator. The integral dx, right? Remember I said it was like a parenthesis or a sandwich, a bookend operator, right? And so where did I put that 1 over 2x? Outside. Am I allowed to move an x outside of the integral? Say no, because it's dependent upon the variable x, right? This guy is saying x is not allowed to be treated as a number. It's a variable. It can't go out of the operation. So that one fails. So now I'm thinking the only choice I have is arctan, right? And I know that if y equals arctan of u, I get y prime is u prime over 1 plus u squared. Well, that's pretty good, right? That's close to what I have, isn't it? If I just think of it in terms of x, and I might as well here, right? Then I get 1 over 1 plus x squared. Okay, so the only thing I don't like is what? The 4, exactly. So we're going to get rid of the 4. How are we going to do that? We could either factor it out or divide everything by 4. Your choice. So now I have 1/4 of the integral of 1 over 1 plus x over 2 quantity squared dx. Yes, you with me there? So I know I have to turn that 4 into the 1, right? So I divide everything by 4. That's fine. That's like multiplying by 1. And then I need something squared here. So I change that 4 to a 2 inside, and it's getting squared. Yes, question? Yeah. Yep. Divided everything by 4. Yeah, it's right out front now. Right? That 1/4 is that 1/4. Now I need a u sub. So u is x over 2, du is 1 over 2 dx. I have a 1 over 2. I have a 1 over 4, right? That's 1 over 2 times 1 over 2. That's my 1 over 4. Oops, dx, sorry. And so 1/2 dx is my du now, right? So I have 1/2 of the integral of 1 over 1 plus u squared du. That's what I wanted, right? So that's 1/2 of the arc. Yeah, 1/2 times 1/2 is 1/4. Yeah, why did I do that? Because I needed a 1/2 dx. So I get 1/2 arctan of u plus c, but u is x over 2. Yep. Exactly. Because I can. What, right? We all agree 1/2 times 1/2 is 1/4. And I needed a half. I certainly could have just done this, and I'll do it this way here. I'll say, well, I need a 1/2 here, so I need a 2 here, right? So if u is x over 2, du is 1/2 dx. Right? X over 2 is 1/2 x, right? So the slope is 1/2. Right? So but if you see, if I said, oh, I need a 1/2, so multiply by 1/2 and then cancel it with the 2, what happens to 2 over 4? It becomes 1 over 2 again. So whichever way you want to do it, that's fine with me. Say again? X over 2? Yeah, in green, right here. Yeah, so it was x squared over 4, but I need something squared. Yep, so if u is x over 2, du is 1/2 dx. Okay? Say again? Yeah, so that's me just looking at my formula sheet. Yeah. Right. I knew I needed a 1 here, right? I need a 1 here, not a 4. So I had to do something to get rid of that 4. So I go through my whole list, right? I go through my whole list. Nothing works. I'm now thinking inverse trigs. Okay? You with me? Yeah. So this is like a y equals mx plus b, right? Y equals 1/2 x plus 3. And so y prime would be just 1/2, right? The slope would just be 1/2. x over 2 is 1/2 x, right? So the m value is 1/2. So if u is x over 2, du is 1/2 dx. Yes. That's right. That's right. So we keep it on the left, we keep it as a du. And then on the right-hand side, I get the 1/2 dx. Again, let's think of it this way. If u is x over 2, and then I use an operator of d dx, right? Yes? On the left-hand side, nothing changes. It's du dx. On the right-hand side, we know it's 1/2. And then I cross multiply, du is 1/2 dx. Question? Nat? So it's your choice, okay? I know I need a 1/2 dx. I don't have it, correct? But I have a 1/4, and inside of that is a factor of 1/2. So I can just grab it. Yeah. So I still have 1/4. You agree? And numbers, constants, coefficients can move in or out of the integral. It's a sum. It's like I'm distributing or factoring. Question? What? Say again? Oh, yeah, I will. Yeah. Yeah. Where are we? Yeah. Well, that's your understanding of fractions, right? Even though I had a 1/4 here, right? Isn't the 1 in the numerator, and the 4 is in the denominator? So when I bring it out front, it stays that way. Yep. Yes. Sure. Correct. That's right. Yeah, so I have a couple of choices here. Let me go back to this, right? So I have a couple of choices here. So just looking at 1 over 4 plus x squared, I could factor. So I could take out a 4 downstairs. And the 4 obviously becomes a 1, and the x squared becomes an x squared over 4, right? So that's one way to do it. Exactly. So the other way I'm doing it, and this is just arithmetic, is I'm dividing by 1/4 over 1/4, right? So upstairs I just get a 1/4. Downstairs I get a 1 plus x squared over 4, right? I'm distributing those. So either way you want is fine. It's funny, right? The things that we have trouble with are not calculus. Calculus is easy, right? The calculus is easy. All right, let's do another one. So level 8. Make it look like an inverse trig, right? Make it look like an inverse trig, yes? Here's level 9. Let's do the integral of 1 over the square root, x plus 1 over the square root of 1 minus x squared. Well, this one clearly has an inside, right? But you should kind of already see arcsine here, right? Yes, you with me here? Yep. So for sure, I think I need a u sub, right? So I need a u sub of 1 minus x squared, and then du is what? Negative 2x dx, right? So in this particular case, I can get that negative 2x dx, but I'm going to have something left over, right? I'm going to get negative 2 times this x plus 1 over the square root of 1 minus x squared dx. So I think I've got a u sub here. In fact, I do. But now I have a negative 2x minus 2 over square roots of 1 minus x squared dx. And so what I want to do is divide and conquer, right? I'm going to divide and conquer here, right? So minus 1/2 of the integral of minus 2x over square roots of 1 minus x squared dx, and then a minus 1/2 of the integral of minus 2 over the square root of 1 minus x squared dx. So I have to do a little bit of work here. I see it's a u sub, but then I realize it's going to turn into an arcsine. Question? Yep. Yeah. I have to cancel it. I can't just double my money in the bank. I can double it and divide by 2, and then. Yeah. Yep. Question. We're not. It happens, and that's the thing, is you have to let things happen. I'm trying to get a negative 2x dx. I can by multiplying by negative 2. It just so happens it also gives me an extra piece that I have to think about, and that piece is divide and conquer. So in my first integral now, I definitely have 1 over square root of 1 minus u squared du, right? Oh, sorry. No, I don't. The whole thing is u downstairs, right? Square root of u. But my other one, you see, is really recognizable right away, isn't it? What negative 2? Yeah, negative 2x dx is what? Du, yeah. So look what I get. I got an arcsine of x, right? Minus 1/2 of u to the minus 1/2, add 1 to the power, divide by the new power, add a function, a constant c. Right? I switched the, right? For the second part, because I recognize that that's arcsine. Yeah. So I could just recognize it as an arcsine. I could recognize it as a u sub and then a leftover piece, right? And now comes the worst one, completing the square. We ready yet? Nope. Yeah, exactly. Minus 1/2 times a minus 2 is 1. Yep. All right, you ready for the tough one? No, not yet. Yep, correct. Where are you right now? Okay, on 5. Oh, yes, thank you. Thank you. Very good. You are the best. Thank you. You imagine originally u was 1 minus x squared. So when I put it back as a u, I made a mistake. Yeah, 3 to 4. So 3, I did this integral first because I know it. And then this one, it's the minus 1/2 is there. 1 over square root of u is u to the minus 1/2. But I'm adding 1 to the exponent and dividing by the new exponent. Say again? Yep. I just plugged in the 1/2's canceled, right? And then u to the 1/2 is half power is the square root, and u is 1 minus x squared. Say again? No, done. How do we check? Derivative. Next level. Here we go. Level 10. Complete the square. Remember how much we tortured you this in pre-cal, only so that you could be ready for this problem. What's that? Level 9 is a U sub with a trig. I didn't really give it a name. I just said it's so. First level of inverse trigs is just got to arithmetically fix it, right? We had to divide by 4. Next level is it'll be a U sub, but there'll be a leftover piece that will turn into our inverse trig. Yeah, that's what we just did. And the next one is complete the square, and the last one is complete the square with a U sub. So 11 levels. I'll just grab one off of here. This is 65. So I've got 1 over x squared plus 10x plus 30 dx. So here I'm doing my list, right? Okay, I don't recognize it. It's not a power rule. I can't, the whole, clearly only the whole downstairs would work for me, but du would be what? 2x plus 10? Can't make that happen. So then I'm on to my inverse trigs, and I think it might be an arctan, right? What do I remember about arctan? I need the integral of 1 over 1 plus u squared du to get arctan of u, right? So I'm going to try and see if I can get this thing to be a quadratic by completing the square downstairs. So I've got x squared plus 10x plus 30, and I'm going to rewrite that as the first two terms grouped together, right? And I want to factor out, I want the leading coefficient of x squared to be 1. I will keep it as 1 for you. If I did my 12th level, it would be the leading coefficient would not be 1, okay? So, but in this case, I find the value of k. I get half of it. I square it. I add it on the inside and subtract it on the outside. You remember completing the square? Just lie to me and say yes. If your pre-cal teacher didn't torture you with it, I suggest a lawsuit. Get your money back for pre-cal. So I get 5 plus x plus 5 quantity squared. So I'm trying to turn it into a 1 plus u squared, right? Yes, you with me? Trying to turn it into a 1 plus u squared. So look at what I have now. I have 1 over x squared plus 10x plus 30 dx is now the integral of 1 over 5 plus something squared dx. Okay, that's good. That's what I want. But I want 1 plus something squared. So I have to divide everything by what? By 5. Good. Yeah, I get my x squared plus some number times x. That number in front of the x term, I call it k. I find that k value, I get half of it, I square it, I add it on the inside, subtract it on the outside. I don't like that 5 underneath my x plus 5, right? So I got to get that inside of the square symbol, right? This one. I need it to be something squared. So what am I going to turn it into if I put it in on the inside? A rad 5. Now look at it. I have 1 over 1 plus u squared. That's what I want, right? Yes. Well, first of all, do you agree if I square? Yeah. So now I need my u sub. U is x plus 5 over rad 5. So du is 1 over rad 5 dx. I have a 1 over rad 5 in my 1 over 5. Right? 1 over 5 is 1 over rad 5 times 1 over rad 5. So I have my 1 over rad 5 dx, right? So the stuff here in green is du, right? Say again? 1 over rad 5? Because that is 1 over 5. Yep. Yep. 1 over 5 is 1 over rad 5 times itself. And I needed a 1 over rad 5. You don't have to do it this way. You could do it the way we did before. Multiply by 1 over rad 5 and cancel it by multiplying by rad 5. Right? That's fine. So if I finally get 1 over square root of 5 times the arctan of u, which is x plus 5 over square root of 5, all plus c. Say again? Yes. Let's go up one more level. Yes, question. Yeah. See, but I'm not doing it. I'm not changing anything. I'm not adding 2. I am always multiplying by 1. So I'm never actually changing anything. But they are equal. 1 over 5 is 1 over rad 5 times 1 over rad 5. You're just not used to it. Right? On the right-hand side, that's 1 over square root of 25. That's 1 over 5. Right? Well, remember, I decided that du was 1 over rad 5 dx. So I needed to take one of them to get my du. No. Well, no, because it goes in. We know it goes in. Because it's we're talking about a sum, right? So if that 1 over rad 5 went in, it means I multiplied it in. If I took it out, it means I factored it out. All right, here we go. Next level. Yep. Yep. Yeah, try it and see what happens. You'll see. It'll fail. It's a good thought, and it's good for us to fail. Okay? It's good for us to fail. Try something and it doesn't work. Right? And that's okay. All right, we ready? Level 10. Oh, level 11. Level 11. Level 12 is most evil. I'll just keep that one out. I'll just go up to 11. This is in my Shawm's book, number 68. Well, initially, it's pretty It's easy. Initially, it's clearly a u sub, u downstairs, right? So what do I get when I let u be the downstairs? I get x squared minus 4x plus 8. And then, of course, du is what? 2x minus 4 dx, right? Well, I definitely can get the 2, right, for the 2x. That's not a problem, correct? So I'm going to multiply by 2 and divide by a half. Sorry, divide by 2. And then let's see what I have upstairs now. I have 2x plus 2. Oh, darn it. What did I want? I wanted minus 4. So what I'm going to do is add nothing. So I'm going to do 1/2 of the integral of 2x plus 2 minus 6 plus 6. Remember, what do I want? Oh, plus 8 here, sorry. What do I want upstairs for my use of? I want 2x minus 4, right? You with me? Nice. So if I divide and conquer, you see I have a 2x minus 4, and then I have a plus 6. Yeah, you with me? Yep. So I'm going to divide and conquer. Yeah, no, this is it. This is the second most difficult level. So I'm going to divide and conquer. So I have 1/2 of the integral of 2x minus 4 over x squared minus 4x plus 8 dx. Okay, that's going to turn into a 1 over u du. And then I have a 1/2 of the integral of 6 over x squared minus 4x plus 8 dx. We okay? Yep. So this first one is 1/2 of the ln of u, right? Hopefully you can see that. I already know I have 1 over u du, right? The second one I have to complete the square. So I'll work on that on the side. X squared minus 4x plus 8 is x squared minus 4x plus 8. K is negative 2. Square it is positive 4. Add it, subtract it, and I get x minus 2 quantity squared plus 4. Say again? K is negative 4. Half of it is negative 2. Yep. What don't we like there? Yeah. Yeah, so this is u, right? 1 over u, and upstairs is du. Yep. I did skip a step there. Remember, this is not on your quiz on Monday, okay?